Alright, so we're going to test for some even-odd functions, which also are associated with symmetry. So the biggest thing that you can do is just plug in a negative x anywhere you see an x and see what happens. So if we plug in a negative x to this equation every single time, we've got to see what happens from the original equation. So negative x to the fourth is going to make it a positive, so 8x to the fourth. Negative x squared is also going to stay positive. Compare your function to its original. It's the exact same, so none of the signs changed. That tells me that this is an even function, and I remember it because none has 4 letters, even has 4 letters. Now if we do the same thing, you can get to the point where you do these without writing it down, but I'm just showing you what we're doing. Negative x to the third is going to make it a negative x to the third. I'm going to pull that out front, so negative 6x to the third. A negative 9 times negative x is positive 9x. If we compare to the original, we see how all of the signs changed. That tells me it's an odd function. Now, and I remember that, all has 3 letters, odd has 3 letters. So if none of the signs change, it's even. If all of the signs change, it's odd. And then obviously, if some change and some don't, it's just neither even or odd. So if we look up here, if I plug in a negative x, that's not going to change. This one will. This means that this function is neither. And then be careful here. If I plug in a negative x to the fifth, this will change. If I plug in a negative x, this will change. And some people see that and say, okay, all of them change, it's odd, but there is no way that you can change that negative 9 into a positive 9. So this would also be neither even or odd because of that constant there at the end. Now, it doesn't mean it couldn't have been even with none of the signs changing, but because this changed and that didn't, that makes it neither.